A lot of first-year engineering students don't know that much about what an engineer does in practice. They know that there's a lot of math and science involved, but there's a lot to learn about what engineering looks like in practice. I think it's really important to start engaging with professionals to learn more about what engineering looks like as a profession and sort of on the day-to-day. So today I'm going to be talking to 4 different engineers who work for Verily. I'll let them tell you more about what Verily actually is.
Verily is a very unique medical device company. It has a startup vibe, but it has the maturity and infrastructure and funding of a much larger company. Verily focuses on devices, services, and long-term science, which is different than most companies that might just focus on a device or a service or long-term science. This maturity, along with the breadth, we have multiple devices in multiple spaces. Again, this is very unique. Most companies have 1 or 2 devices in one space, as well as the exceptional nimbleness makes it a really engaging and exciting place to work.
We're talking about this fast-paced culture, where engineers can have ideas for different devices or products or techniques or processes from the science side, and we can quickly test them out to see if they succeed or fail, and if they succeed, they could kind of move on, or if they fail, then we move on to the next thing. So there's a lot of innovation happening here at Verily very, very quickly.
So can you give me a feel for what you do?
So my name is Adam. I am a mechanical engineer. I've been working on the smart contact lens project with all the other brilliant folks on this call. My main role is providing automation solutions for the manufacturing of these contact lenses. During the early startup phase of this project, a lot of these devices were being made by hand, and they're very fragile parts, and they require incredibly precise placement, and it's just a really challenging thing to do by hand. So I've been working on purchasing robotic arms off the shelf and designing a system around those that will handle these parts and do all of the assembly processes. I think this would generally be called like automation or maybe mechatronics, so that the work isn't strictly mechanical engineering. I need to know about electrical engineering a bit in order to specify various sensors, power supplies for the system. I basically did all of the electrical layout. There's also a need for software knowledge in order to program the system to make it work. So I personally really like that variety that I can get. Verily is a unique place, and I think it allows me to do all of those roles, just given how much we're trying to accomplish. I think sometimes at a larger company, somebody would maybe be more likely to be stuck doing only one of those things. One person's doing the mechanical design and doesn't ever touch software or electrical work. So that's one thing I really value about the type of teams that we work on here.
I do product design, mechanical design, and clinical engineering. My discipline is mechanical and system design, and my job title is product design engineer. I'm primarily responsible for the mechanical system design of a 5-part assembly. As Adam mentioned, it's a contact lens. This assembly has tolerances in the single-digit microns. Previously, I worked in tens of millimeters and then millimeters, and now another 1,000-fold down to microns. This includes oversight of manufacturing processes for injection molding and cast molding, as well as the scaling models and the metrology systems that enable us to hit these precision dimensions. The final assembly is a contact lens, so it's a wearable. And I'm also responsible for the user contacting surfaces, i.e. I need to make this thing fit general population and be comfortable in that general population.
My background is actually kind of in electrical engineering. My degree is in biomedical engineering with a concentration in electrical engineering. So that's what I did in undergrad. That's what I did in grad school, namely around microelectronics and microfabrication. So small electronics. Here, at least within the context of this contact lens project, my technical, I guess my role would be the manager, I guess, for what we call the pilot line. The pilot line is a small scale manufacturing line. So you can think of it as, the contact lens technology that Adam and Jeremy have been talking about. Using Adam's robots and using Jeremy's designs, we need to figure out how do we go from making just 10 or 20 of them to making 100 of them a day. And that's basically what the pilot line does. As a part of that process of maturing a technology or maturing a device, you can start with manually, assembling or manually manufacturing tens of these contact lenses, to working with robots, to working with more people, to working with different and easier or faster processes so that we can crank out more of these contact lens units a day. And basically my role, I guess, or my title is technically hardware engineer, but you can think of me more as a R&D or like a process development engineer. My job is to make sure that this pilot line never stops manufacturing these lenses. And if it does stop, that stoppage only occurs for a very, very short amount of time.
My background is in materials science engineering. And so I was fortunate enough to kind of come in at the very beginning of this smart contact lens project when it was just kind of getting off the ground. And so early on, my role was kind of, as Jeremy and everybody here's mentioned, I wore just about every hat. At this point in the project, Adam is building the robots that are doing the assembly that I was doing manually for, the first half, for the first couple of years. So Brian and I were working under microscopes, doing a lot of the things that robots are now doing. But of course, you can't build a robot if you don't know what the robot needs to do. So that's kind of how you sort of discovery. And then as a materials engineer, what one of the primary roles that I've played is developing some of the unique materials that are necessary to make this device meet certain specifications. And so that ranges from screening different adhesives to probably the most complicated specification on this project has been combining, electronics, display technologies from your phone and different things like that, different advances in materials, but then also how do you get all of that into a biocompatible package that can go on somebody's eyeball? And then on top of that, how do you make it permeable to oxygen? Because, a lot of times you think about most electronics are trying to keep oxygen and moisture away. And we're like, well, yeah, that'd be nice, but we got to get oxygen through to the eyeball. Otherwise, this thing is a non-starter. Developing and discovering a new class of materials that is oxygen permeable and yet also electrically conductive in certain places. We had to develop a transparent conducting material that is oxygen permeable.
What does a typical day look like for you?
In the mornings, we have a team huddle. That's about 20 minutes, 30 minutes, 40 minutes, depending on what we need to talk about. A good part of my day is in SolidWorks. It's a CAD program, designing either parts or associated fixtures. A good part of my day is analysis. This can be data analysis in general, failure analysis, dimensional analysis, root cause analysis. This is on the manufacturing side as well as on the clinical data side. A good part of my day is brainstorming or problem solving, and this often involves team members, and sometimes there's various one-on-ones or team meetings that'll typically fill up a day.
In a normal day, as Jeremy mentioned, we have a huddle to figure out what are the priorities of the day, and then the rest of my day is largely just putting out fires. So let's say on one aspect of that manufacturing line, something goes horribly wrong. Engineers have to be at on call and ready to go and fix that problem so that these lenses can continue being manufactured. And that's basically what I do on a daily basis.
Nice.
And what's really cool is, like I mentioned, my background is in electronics or in electrical engineering, and Adam had mentioned this is a smart contact lens. So from what I get to touch, as what Adam said, it's a variety of disciplines, whether it be from materials, so we're talking about chemical engineering, to mechanical engineering, to electrical engineering. I'm also kind of fortunate, like Adam and Jeremy, where I could get a large breadth of all the engineering disciplines in the role that I have right now. And I think that's something that as Adam and Jeremy mentioned, is pretty unique to Verily. We get to all wear lots of hats, and it makes the job really fun.
My typical day, as Jeremy and as everyone's mentioned already, the day starts with a huddle. There's various meetings. I tend to spend a lot of my time in the lab formulating different chemistries for, adhesives and rigid gas permeable materials. I run a lot of tests on those types of materials. And so I spend quite a bit of my time in the lab, but then also providing insights in these huddle meetings and helping put out the fires that are material related.
What were your experiences prior to your current job?
Before this, I had worked at a renewable energy consulting firm for a few years, doing also mostly mechanical design in that role. I worked at a hydropower startup company doing mechanical design and some industrial controls. And then I worked at Google X on a robotics project, also doing some automated testing of components. Everything was sort of related. There's always been a bit of software and a bit of hardware. This is sort of the role that I had always envisioned I would want after I graduated from school.
I've worked at a large multinational company. It was a medical device company. I've worked at a medium-sized company, and then I've worked at 2 different startups. Most of these have been in the medical space, and in each case, it was in the mechanical design side or in the process engineering side. I would say all of the companies all had deadlines. They all have an aggressive work schedule. They all have some sort of quality system overhead, being in the medical device world. And I would say the thing that's different about Verily is the transparency. There's no bureaucratic overhead. There's no hierarchy. Everyone is very open about every detail. That's not necessarily true at other companies I've been at. Another thing that's different is incredibly talented peers. Verily and Google hire just top of the notch people. And impressively and thankfully, there's been a really good focus on personal and career growth, and that's encouraged at Verily. Other companies are like, just get your job done, and Verily is like, no, how do we make you better so we can get you to perform better? We have a pretty large tolerance for failure. We have a term, fast to fail, and it's okay to fail, and it's a good thing to fail because we're learning from them. And we work on some pretty bizarre projects, and so our overall risk tolerance is also a little bit higher than most companies.
This is actually my first job out of grad school. So unlike Adam and Jeremy, I'm kind of fresh off my degree. I've been here for like five years now, and what I love about Verily and what I love about this experience is the fact that I get to wear so many hats. So as Adam mentioned, like if I was probably at a larger company, I would probably only be doing, I don't know, like one thing, let's say like electronics testing or assembly or design, and I'll just be stuck doing that the whole time. I think I got really lucky. I hit the jackpot here because I get to, really explore all these different disciplines, even though my degree is kind of, very concentrated within this small, like niche discipline of microelectronics. But yeah, it's been a blast here.
Let's see, in the past, obviously I was a professor. I did have a job in a national lab for a couple of years, doing research on biomaterial interface, the interface, the way that cells respond to materials. And so that provided a good background for, some of the biocompatibility issues that we have on this project as well.
Awesome.
Differences, certainly there's vast differences between academia and industry in terms of just the cadence of the work, and the sort of the cycles, in academia, there's the sort of, you have the cadence of the semester and you start and stop things on a pretty well-defined schedule. You have end dates that are very, you can't just arbitrarily decide, oh, you know what, we didn't learn enough, or this class didn't quite learn everything I wanted, so we're not going to take our final until middle of next spring. Can't do that. And so there's interesting ways that deadlines are approached and moved around and shuffled around based on change, the dynamics of the situation. But on a different token, having that endpoint kind of does provide a sense of closure and then a new beginning. Whereas here, sometimes, if a project keeps dragging on, you can kind of you can't get to that new beginning. However, as they've said, Verily does have a lot of pretty cool projects going on, and so there are always opportunities to dabble in new beginnings.
What were some of the most critical undergraduate experiences that you would say prepared you for what you're doing now?
For me, I think the biggest thing in my undergraduate education that prepared me for this was just I took ownership of my education, and I went and I approached a professor and I said, you do something that's fascinating to me. I want to be a part of it. How can I get into your lab? And I offered to wash glassware because at the time I didn't think I was worth anything, and I didn't know anything. And so I thought, well, if I can at least wash glassware in his lab, I can start to, see what it's like and figure out how I can be like that professor and do the things that that professor was doing. That foot in the door just opened up opportunities to do some independent research and see what went on outside of the books. In my mind, that's the thing that really prepared and sort of set the stage for all that came after.
Actually, it's cool that Scott brought that up because mine is pretty similar. The thing I think that really helped me out when I was in undergrad was all the kind of open-ended research projects that we had. We had a senior design project in my undergrad where it's usually tied to a course, and it's they give you, or you have to go out and find your own problem to solve from a device point of view. Like I mentioned, my degree was in biomedical engineering, so I was taking an optics-based senior design course. So you would have to figure out, hey, like what's a problem in the world that you can solve with a particular device, and then create a prototype of that device. So it's like an early stage research project. And then along this similar vein to Scott, another research opportunity that I had after speaking with a professor whose research that I was really interested in, also open-ended, where the professor, I expressed my interest to the professor, like, hey, I'm really interested in your research. Is there any way that I can help your grad students or your work? And she gave me another kind of open-ended question, like, hey, like, can you explore this? It was in mathematical modeling at the time, but it was another open-ended question. And then she let me kind of find my own path to try to answer that question. In both those experiences, it's really cool to take what you learn in class, or use those principles or use those concepts to do your own research, whether it's in literature or on the internet or by speaking with other experts, and try to come to a conclusion or a finding, or in the case of my senior project, an actual prototype. Based on that experience, I was like, oh wow, I'm like really interested in doing research, in having a nice product at the end of it. That inspired me to go to grad school, get my PhD, and then eventually work at Verily.
For me, I remember taking an elective in mechatronics, which was really where I found something that I was really excited about. We learned about microprocessors, which I hadn't known anything about, and my group made a machine to solve a Rubik's Cube. We also learned, we were working until like 4 a.m. the morning that it was due. And just as we finished up, we learned that if you don't properly ventilate an enclosure, heat will generate and will fry your electronics. So we did not accomplish our goal, but we did learn a lot. And I think that was what set me on this path. I also have a similar story of reaching out to a professor. He was a professor emeritus, and he had started a robotics company. And so I just walked up to his door one day and asked if he had a position available. And so I ended up working as an intern for 3 semesters at his company. That was the first time that I really got software experience. It was really great for both my resume and also solidifying my sense that that's what I was interested in. So I'm sensing a trend here of talk to your professors and get to know them.
I would say I wanted to start with the engineering fundamentals and the design courses really establish a solid problem-solving approach of how to approach a problem. You have your assumptions, you have your givens, you have your equations. How are you going to solve a given problem? From there, for me, it was really the extracurricular clubs that were at the university that I went to. We did not really have a graduate program, so there weren't teachers or labs that I could go to. Our school had a learn by doing approach. And so most of the courses had a practical component. And most of the advisors, instead of having a lab, had a club. So there was the ultra mileage vehicle club, there was a human powered helicopter club, there was the solar power club, and each of the mechanical engineering professors kind of ran one of their own clubs. And the clubs really gave a sense of teamwork and a sense of real world problem solving. So you had your book problems, but you could actually go and you had to build a device, and that device had to do something. And often that device was entered into a competition against other universities around the country. It gave a practical experience to the theoretical learnings, and it allowed for really good learning experiences. Basically, similar to Adam's story, we failed a lot. And it's good to fail because you can learn a lot from those failures. I actually learned a lot from leadership in team sports. So there was a lot of organizational issues in teams. You have funding, you have membership, you have recruiting, you have training, you have planning, you have logistics. How are you going to get to the race? How are you going to move stuff around? So it was really good lessons in teamwork and camaraderie and kind of interpersonal dynamics. You have different people on your clubs and your teams, and they want to do certain things a certain way. And learning to work with those people and learning to, and sometimes lead those people if that was the goal. That was a really good experience. Similar to the vein that you guys were talking about, reaching out to professors, I would cold call people in industry and just ask them, hey, can I have 20 minutes? Tell me what your job is. And I really, really thought I wanted to go into computational fluid dynamics. And I talked to a guy and he said, I stare at dots on a screen all day. And he was at NASA. And I was like, nope. I wanted to go into hydrodynamic design and design sailboats. And I talked to one of the guys that designed the America's Cup boats. And he said that was 5% of his job. 95% of his job was designing passenger ferries. But that 5% was awesome. And I asked myself, how much of my job do I want to be awesome? Do I want it to be 5% or do I want it to be more than that? And so instead of cold calling professors, which I totally support and agree with, and you see the wins from the people here, do the same for people in industry.
What's a piece of advice that you wish you had as a first-year engineering student?
The road is pretty long, but it's really, really rewarding. And it's more rewarding if you focus on your strengths. I took a class, I was talking about the grow opportunities at Google, and there was a course that described a strength as a combination of your gift, your passion, and your talent. The things you're born with, things that you develop, and things that you just absolutely love. You can do jobs and you can go through life working on things that aren't a strength, and you're going to struggle a lot. But you're going to have so much more fun, and you're going to make so much more money, and you're going to be so much happier if you focus on something that is a strength. And I've kind of, railed against the walls of things that I'm not good at, and I've finally landed in something where when I'm working in my strength, and it's great.
I don't know that I was really prepared for the differences between school and work. I was really good at school. I was really good at getting the answer to the problem. And once I got into industry, there's no longer the answer. There are like 1,000 possible answers. There's maybe no best answer. That certainty that I used to have finishing a test where I'm like, I know that I got those answers right, that was gone. Like you no longer got a grade that said you have an A, and it was a really rough transition. And so I guess the thing I wish that I knew, your worth as a person is not driven by your ability to do your job. I think there was a certain amount of stress that I took on that was unnecessary, that really made the first few years out of school not very fun. If you can find a way to approach things you're not great at yet with a not understanding that you're learning, instead of seeing the failures, I think that that would make the transition a lot better.
The biggest advice that I would give to myself when I was starting out as a first year engineer is to not really stress about the future, and instead try to find things that excite you. whether it's from a topic or a concept or a device or a process. At least for me personally, I was very worried about like, okay, what am I gonna do after undergrad? Like, how do I like set myself up for that? I didn't really realize until like my senior year, hey, like I'm really passionate and I'm really interested about research in devices, in medical devices. So, that like started this whole path.
I didn't realize how much materials drive decisions in design choices. And I really wish I would have learned much more about materials, material science, chemistry. I can't tell you how many times I've had a bond fail and the chemist goes, oh, it's amines. And now I know exactly what that means and why the bond failed. But if I would have known that a little bit beforehand, I would have made some different choices and some designs would have worked the first time instead of having these failures.
The engineering education was incredibly myopic. It was like laser focused on technical work. And at the time, I thought that was wonderful because that was all I was interested in. And based on my limited understanding of how the world works, I would tackle the world's problems through mechanical engineering. I didn't appreciate the value of history, the value of understanding more about politics, public policy. These other things that as I'm older and I'm focused on how do I put my work to make the world a better place, I realized more and more like mechanical engineering is not the only solution, and it's probably there's a very limited subset of things that I can actually fix with my knowledge. So yeah, I guess I wish I had taken more courses and been more well-rounded.
There's a lot of other job roles that isn't necessarily like a process development engineer or a design engineer or a manufacturing engineer. There are other roles that you can kind of explore if you're interested in that. So let's say, there's like program management, product management. So you can take all the stuff that you learn from the engineering side and you can use it to help drive a project. You can be a technical manager. There's so many roles outside of like hardcore engineering that we're typically very used to and very comfortable with. That's another thing that I would have probably told myself to, hey, like try to explore other roles that are out there in addition to engineering. If you're really passionate about a certain field, there's so many ways to be involved in it. It's just kind of up to you to find out all the different opportunities that you have available. And there's a lot.
Engineering is not just math and fundamentals and problem solving. You really need skills in interpersonal interaction, understanding, presenting, and analyzing data. My undergrad had, I think, a single class, not a course, a single class, maybe 2 or 3 hours on statistics. I use statistics every day, and it's something that we use for understanding problem solving. Additionally, time and project management skills are pretty critical. If you don't have these in life, you're not going to have them at work, and you're just going to be miserable a lot.
I think I kind of looked at the world as this sort of fixed, static, zero-sum game reality, where some company made something, I was going to go work for a company and I was going to contribute to the value that company added to society, and other people were going to then define that value. And I think what I would tell my younger self is that's kind of a very limiting perspective on the world.
That combination of like what you kind of learn or what you're good at and like what you're passionate about or what you love doing, I think that really makes my job right now so much fun because I'm passionate about it. This is something that I tell a lot of undergraduates nowadays, like, hey, like find something that really interests you and don't stress about it if you can't find it like right now. Use the time to explore mechanical engineering, explore electrical engineering, mechatronics. We didn't even have robotics or mechatronics at my undergrad, so I didn't even know about that until I actually when I got to grad school. So there's so many different disciplines, engineering disciplines, so take your time to explore what's at your university, explore what's out there in industry, and find something that you're passionate about, because that's what's gonna make work fun and work enjoyable.
To those of you here who participated, I just Thank you so much for taking this time. You all have very interesting experiences and perspectives, and I'm really glad that I'll be able to share those.
You can create value. You can convince people that you can create value. To the extent that you can, try to create the world that you want to live in. You can do that. It might be tough, it might be hard, but as a young person, I didn't see that. I wish I would have started thinking a little differently, maybe a little earlier about that.